Hey Algebra 2, today I'm going to teach you how to complete the square. So the goal is to take an equation that looks like this from standard form and move it into one that looks like this, which is vertex form. So you'll notice that the only letter that stays the same is the A. So the A in standard form and the A in vertex form is the only thing that's the same. This has a B and C. This has an H and a K, and that is the vertex. So in order to do that, we have to take a quadratic in standard form, and we have to turn it into a perfect square trinomial. So when I do that, I'm going to make my ACB chart. So once again, there's my A, there's my B, and there's my C. So I need factors of 9 that add up to 6. So 3 times 3 is 9, and that adds up to 6. So I would write this as x plus 3, x plus 3. Anytime that you have anything times itself, we can just rewrite this as x plus 3 quantity squared. When we do this one, it actually doesn't matter if this sign is a positive or a negative. What you do have to have is the last one, they both have to be positive. So when I make, there's my A, there's my B, where's my C? So when I make an ACB chart, 1 times 25, so I need factors of 25 that add up to negative 10. So 5 times 5 is 25. Oops, that's plus 10. A negative times a negative equals a positive, and that adds up to negative 10. So this we would write as x minus 5, x minus 5. So since they're the same, we can write that as x minus 5 quantity squared. So we want to find numbers kind of like that 9, like that 25 right there. So we want to figure out what should that value be. So it says find the value of C that will make a perfect square trinomial. So here are the steps to do that. It says you have to take B divided by 2, and then we're going to square it. So there's my A term, there's my B term. So it says to take B divided by 2 and square it. So B is 22 divided by 2 squared. 22 divided by 2 is 11. And 11 squared is 121. That is the value that will complete the square. So if this read x squared plus 22x plus 121, we could factor it just like we did the prior two. So as we're going to come to find out, whatever that number is right here, that's what ends up showing up in the parentheses. So this will factor as x plus 11 squared. So if you want to look back here, that number ended up there. That number ended up there. What is the value that will complete the square? So there's your A term, there's your B term. So we're going to go B divided by 2 squared. So your B term is negative 4 divided by 2 squared. That equals negative 2 squared. And then when you square it, you get 4. So 4 is the value that will complete the square. So we have x squared minus 4x plus 4. So once again, whatever is right there, that is what will go as your factor. So this factors as x minus 2 quantity squared. You can try 5 and 6 and check my notes. Let's do one that is an equation that we actually have to solve. So to solve this, it says that a must be 1. So in this level of Algebra 2, a is always 1. In honors and in pre-cal, they might change it up, but we don't here in this course. It says isolate the x and x squared terms. All right, so we want the x squared and the x term on one side all by itself. So that means we want you to move the constant to the other side. So I'm going to write this as x squared plus 10x plus blank equals 11 plus blank. So once again, there's my a term, there's my b term, there's my c term. So when I move the constant to the other side, I'm doing just like I did before. I'm figuring out what is the value that will complete this square. So we're going to go b divided by 2 squared. So b is 10. 10 divided by 2 is 5 squared. And this equals c that we're going to add to each side. So I'm going to not write that out as 25. I'm going to write it as 5 squared. Factor the polynomial. So on the left side, this I've come to learn factors as x plus 5 quantity squared. So whatever number you get right here at this step, before you square it, that's the number that shows up in your factor form. All right, so on the right side, though, we are going to have to finish squaring it. So 5 squared is 25, and 1125 adds up to 36. So we would like to solve this equation. So anytime that you have an exponent of 2, what you need to know is square roots undo exponents. So as long as you do the same thing to both sides, that keeps it in balance. The radical knocks out the exponent, so you have x plus 5, and the square root of 36 is 6. Oops, my bad. Anytime that you take the square root of a number like this, you always get 2 answers, a positive 6 and a negative 6. So then I just need to subtract the 5 over to the other side. So one of them is x equals 6 minus 5, and the other answer is x equals negative 6 minus 5. So when I finish solving this, 6 minus 5 is 1, so one of your answers is x equals 1. Negative 6 minus 5 adds up to negative 11. So the answer to this problem is 1 and negative 11. Let's do 9. All right, so we just want to isolate x squared and x on one side. And I'm going to subtract the 12 over. I have x squared plus 8x plus blank equals, that adds up to negative 22 plus blank. All right, so there's my a term, there's my b term. We're trying to figure out your c term. And a long time ago we learned that as long as you add the same number to both sides of an equation, that will keep it in balance. So what number shall we add? you use the formula b divided by 2 squared. So b is 8. 8 divided by 2 is 4 squared. So 4 squared is the number that we're going to add to both sides of our equation. On the left side, I know now that this factors as x plus 4 quantity squared. On the right, so 4 squared is 16. Negative 22 plus 16 adds up to negative 6. We're going to take the square root of both sides because radicals cancel out exponents. So I have x plus 4 equals plus or minus the square root of negative 6. I'm going to subtract the 4 over to the other side. And x equals negative 4 plus or minus the square root of negative 6. So we can't leave a negative under the radical. Fun fact, the square root of negative 1 equals I, an imaginary number. So anytime that you have a negative under the radical, we are going to turn that into an I. So x equals negative 4 plus or minus I radical 6. And that is your solution for a good final answer on that one. Oh, what shall I do next? I should do number 12. 12 looks like a good one. Okay. So we have to get x squared and x on one side all by herself. Send the 1 to the other side. So I have x squared plus 3x plus blank equals negative 1 plus blank. So there's my a term, there's my b term. So to figure out what number it is, b divided by 2 squared. So b is 3, so I have 3 divided by 2 squared is the value that I am adding to both sides. So this is the first time that we've had an odd number for our b term. And so when we have an odd number, we are going to end up with a fraction. That's okay. All right, so how is this going to factor? Well, nothing changes. Whatever number is right here, that's what is going to end up going in the parentheses. This left side factors as x plus 3/2 squared equals, all right, so 3/2 squared is 9/4. Negative 1 plus 9/4 equals 5/4. I need to solve for x, so I need to take the square root of both sides. The radical cancels out the exponent, so I get x plus 3/2 equals plus or minus. All right. So when you have a fraction under the radical, I notice that 4 is a perfect square. You can rewrite this as the square root of 5 divided by the square root of 4. The square root of 5, I can't take that, so I still have the square root of 5. But the square root of 4, that's a perfect square, and that equals 2. So I need to solve for x, so I'm going to subtract my 3/2 over to the other side. I'm not sure if we've done quadratic formula or not, but you usually put the number first and the radical second. And so x equals negative 3/2 plus or minus the square root of 5/2. And check the notes for the other one. Thanks.